Wow. Dava, we're in space, deep
Thank
space.
goodness. We'd be hanging from the rafters.
This is exciting because, look, you're here for the first panel of the day, and this is one of the coolest of the tremendously cool panelists all day long. Dava Newman, you know, the title Deputy Administrator seems almost, well, it just doesn't seem to describe the incredible career you've had and the tremendous interest you've had. For a woman who started out in a small town in Montana, you are going out into the deepest parts of space and asking the deepest questions. And we want to begin out there with a look at deep space from Hubble.
Excellent. So why explore? We can cue up the first slide here. It's really the enduring questions that we have. Are we alone? Are there other habitable planets? And when it comes to Mars, did Mars once have past life? So that's really why we explore, you know. And the evidence is mounting, Joy, for lots of evidence for thousands and thousands of other galaxies. You know, life elsewhere in the universe.
Thousands of galaxies. I mean, we see these images and we're moved by these images. But you were telling me that we can see images now. We know about things down to my thumb.
So if we looked at this, as I love these Hubble images, we've had Hubble 26 years exploring. Amazing. So anyone in the audience, I think we have students and university folks here, 26 years and younger, your entire life, Hubble has been peering out into the solar system. We've looked back now 13 billion light years, and what did we find? When we looked at the dark spot in the sky, it said Hubble, it's kind of like a long exposure photograph. Look there for 10 days. You know what we found?
What?
In something as big as your thumbnail, 10,000 new galaxies we didn't know about.
New galaxies, 10,000 new galaxies in my thumbnail.
Thumbnail, dark spot. And James Webb Space Telescopes, that's next. 100 times more powerful than Hubble. And James Webb is in infrared. Hubble is an optical telescope. So again, are we alone? And are there other habitable planets? We're just peering into the solar system. And I like to make the point that all of our exploring out in the solar system, what does it tell us most about? Life here on Earth. It all comes back to reflecting on humanity and life here on Earth.
And it may also tell us about what our future is off Earth. You say that we could be interplanetary creatures?
I have no doubt that we'll be on Earth and we'll be on Mars in the coming decade or two. And that's what we're working on as our journey to Mars at NASA. And we're already on the International Space Station. For 16 years, nonstop, we've had astronauts from all over the world living, working together to expand how long can we live in space, making the technology investments in microgravity. But we move, that's phase one of our journey to Mars. And I think we can cue the next image here. It's a three-part journey to Mars, starting with International Space Station, just in low Earth orbit. We move out next on the Space Launch System from Boeing. Lots of partnerships, you know, public-private partnerships. The next big heavy lift launch is our Space Launch System with the Orion capsule on top. That takes us back to the moon, to moon orbit, Earth-moon orbit. We call that deep space. And that's where we really need to make the technology investments. We have 85 technologies we track, but you know, there's half a dozen that we have to test in deep space. In-space propulsion, solar electric, deep space habitats. Where and how are people going to live? Life support systems.
And the suits. I mean, the very suits. Now, this is something that Dava has been absolutely instrumental in reconsidering what a spacesuit is. We are accustomed to thinking of a spacesuit as the Michelin Man, right? But that is not going to work when we get to Mars.
So we get to Mars, the third phase, we get to Mars. It's really hard. It's really far away. You have to be completely autonomous. And so when we get there, you need very light mobile systems to empower the astronaut explorer. But it'll be the humans, it'll be our rovers, robots. You know, so I really look at it as like a suite of explorers. But I want those explorers to be just like an Olympic athlete. You know, empower them. How capable can they be? Again, we're going to look for the past evidence and search for past life. It might be 3.5 billion years old, but the evidence is mounting now to see what we'll find.
There are indications of water, beyond ice, water.
Yeah, it's a huge finding. So we've known that there's ice on the caps, the polar caps on Mars, but now we do have the evidence for seasonal water. Now, it's very briny, high salinity. You can't drink it, not for human consumption yet. But just to know the seasonal changes. And again, Mars is probably breathing, talking to us. A lot of methane is coming out right underneath our rover. So what we're looking for, again, the building blocks of life. And when we go there, there's something called in situ resourcing. We have to live off the land. All of successful exploration in human history has been successful when you learn to kind of live off the land. You can't bring everything with you. Bring your few, bring some supplies, but then I challenge the designers, we have to make the maker on Mars. That's the challenge. We don't get to bring it with us. We have to really make it there.
There's so many ways I want to go with this conversation, but what strikes me is you refer to makers, designers. We've been thinking about science and science education, science, technology, engineering, and math. You say we have to go further with this.
Yeah, I think we need to change the conversation, open it up. It was the wrong message. As an aerospace engineer myself, you have to see yourself. I never knew any aerospace engineers. I definitely didn't know any female engineers, so I didn't even know that that was a path.
You were a little girl in Helena, Montana?
Mm-hmm. Grew up in Helena.
And there you've gone all the way to space.
And Apollo really inspired me because it showed me to dream and to dream big. To anything was possible. Humans could go to the moon. And so I got the bug early on for aerospace. But again, I didn't see anyone like me. So I think we changed the conversation. I call it STEAMed. Bring in the arts. Why? The visionaries. Paint my pictures about how will it be when we're interplanetary, have people on Earth, have people on Mars. So the historians, so important. The designers, I put a D on the end for the 3D maker generation, a whole new generation. And most importantly, it's about filtering everyone in. How I was taught, you had to be the best in calculus, the best in physics, the best in chemistry. Well, how intimidating is that? That's not the story. So let's change it. Say, those are tools, but you want to get to Mars, you want to design and build and fly the aircraft. Now we're doing experimental aircraft here on Earth. That's super exciting. Get to Mars, but if that's the exciting part, building, designing, flying, guess what? Those are tools. Okay, you're going to study math, chemistry, but change the conversation so we make sure that everyone is filtered in. No weeding people out. Can't leave any talent on the table.
You are on Twitter at Dava Explorer, and I think this really goes to the kind of person that you are personally. You have just been on an enormous trip, and you brought those things together, both design and engineering, on this amazing trip that you took.
So we sailed our sailing vessel Galatea, our sailboat, and circumnavigated the Earth. I think if you talk about exploration every day for a
That's
job,
a long way around.
It was a long way. It was over 40,000 nautical miles. It's only 22,000 if you go circumnavigate, but we went around Africa and teaching kids, girls and boys all over, about exploration by sea and space. Again, because our exploration, it's for humanity. It's not one nation, not one space agency. It's really exploration for the global community. And I think that's the right goal. And so we survived our circumnavigation, got to teach thousands of kids around the world.
You lost your hydraulics at one point.
We did, across the Pacific, the longest crossing.
Wait, you've lost your hydraulics in the middle of the Pacific.
Yeah, it's about 2,000 miles out from Galapagos. We still had 1,000 miles to go to reach the next rock, which were the Marquesas Islands.
This seems like a very bad idea, but there were talents that you and your husband had, and you were the only two on the boat.
2 people on the boat.
There were talents that each of you brought. I think this goes back to this notion of STEAM. There are talents that each of you brought that may have saved your lives.
Yeah, kind of like our Apollo 13 moment. How do you fix the hydraulics? And again, he's a great sailor. I kind of brought in some of my engineering, technical expertise. It's a long story, but the short story is that we went 1,000 miles on extra virgin olive oil. I think it has to be extra virgin olive oil.
Extra virgin olive oil.
Because it's the same viscosity as hydraulic fluid. Who would have known?
Only an engineer, I guess.
I did the mixing experiment. We had a lot of diesel and water, other things on board to keep us alive. But I had purchased 4 liters of extra virgin olive oil in Panama, same viscosity as hydraulic fluid. So we filled that up, kind of hooked up an IV to our steering, to our hydraulics.
So the maker, the designer, and your husband, he helped you engineer a solution.
Absolutely. You get creative really quickly when you're in the middle of the Pacific, with nowhere to go.
Your thinking about science is so inspiring to me because you have gone and looked at these questions in a different way. So to go back to the spacesuit, you were responsible with this new design in spacesuits. We were referring earlier to the Michelin Man. The future That Olympic athlete, as you describe him, on Mars, what does that have to be? How is that going to be different than what we've seen in the past?
So it really needs to be custom. We need to empower exploration. Again, so I look at it as a kind of custom design. Again, very lightweight, very mobile. We're going there to search for the evidence of life. So you need the people, the astronaut explorers, your rovers, amazing amount of augmented reality is going to help us explore. We're going to have all the AI, the machine learning. We need all of our best systems. And that's where the human and the machines, our rovers and robots, I see it as just one team. All that information. I'm taking a sample. I need like all the laboratory analysis right there. I need maps of 3D topology. Where am I going? People can explore up hills, down hills, rovers somewhat, but we need more capability. So I just look at it as all of this together that really empowers exploration for the future, especially on a planetary surface.
Yeah, I encourage people to go online and read about your suit, your spacesuit, the one that you've designed, because part of it has to do with rethinking how that is, and yet dealing with some of the real physical questions of deep space, the expansion of skin in gases. What happens?
Well, we looked at, in terms of most conventional spacesuit design is gas pressurized, because you have to pressurize the person. Now, you have to apply 30%, so it's 30 kilopascals, or just 1/3 of an atmosphere. We're doing great in our 1 atmosphere having this conversation. But when you go into the vacuum of space, or Mars has a very 1% atmosphere. So you go to these you go vacuum of microgravity or just a 1% Mars carbon dioxide atmosphere, you have to pressurize. First and foremost, you have to pressurize the astronaut. You have to provide all your oxygen. You have to scrub out the carbon dioxide. So again, thinking about how to do that, the way I look at it is a spacesuit is the world's smallest spacecraft. It needs all the systems of the entire spacecraft, but now you're putting it, and it needs to be wearable. So that's why we look at mobility.
So today, the spacesuit that exists today, I wouldn't do very well in, and you wouldn't either.
In the conventional ones, really is they're big, they're oversized. The great thing is they're keeping you alive. So we have to give the engineering expertise. We have to give it a lot of credit.
They work.
Since the 60s, we've been keeping people alive because it really is an amazing engineering feat. It's also thermal control. So it's pressure, thermal control, give the life support. But when microgravity, we're floating around. Right? We're floating around. But when we get to a planet, and the moon is 1/6 G, we get to Mars 3/8 G, let's call it a third, there's gravity. So now we're bipeds again. You'll actually be kind of loping, not the bunny hopping like the Apollo astronauts, and kind of limited mobility in the biomechanics.
They're really going to be able to...
Ideally, so you really want to give them, they'll be loping and bounding, and you can cover a lot of distance.
And climbing.
Climbing, absolutely. Mars's terrain is unbelievable. Olympus Mons, that dwarfs Mount Everest, right? Valles Marineris, the Grand Canyon is cool, right? Valles Marineris will stretch, that's the biggest valley in Mars, stretches across the entire United States. So it's kind of extreme exploration.
And the suits themselves. I made reference to the existing suit today. It's like 300 pounds, something like that?
Yeah, about 140 kilos, yeah, close approaching. But it's for the weightless environment. So that's why mass is not so important.
You can get away with it.
Right.
But for someone of our size, and maybe this goes to why we have not seen as many small people take on the challenges of space. But right now, I would probably not be able to wear the modern spacesuit because it's too big for me.
We have a medium, a large and extra large, and you and I would go into the medium, but we'd rather be in a small, we'd rather be in a tight fitting. So we'd rather be in a tight fitting so that it really works with you. You don't want to have to fight the suit. You want the suit to work with you. You want to use all that energy to go about your exploration. You don't want to be fighting the systems.
And you have really rethought how that will look. And I encourage people to go online and look at it because it really is a different way to think about what an astronaut is and what he or she can do in space. I know this is so important to you, the education element. Can you talk about what we need young people learn, and actually go to the question that you have posed?
So I love to think, I need every single girl and boy out there. Again, I think how we bring people on board, my question is, how do we bring every little girl and boy with us on this journey to Mars? It is for them. Everything I do is for the next generation. I call them we had the millennials, right? And now I think after that we have the Mars generation. That's what I call the kids in school today, because they're going to be the ones boots on Mars in the 2030s. And again, I think we just open it up. And we're really pushing it, and as we're pushing citizen science and open data, we're at Jupiter. Did you know that? We're in orbit around Jupiter with our Juno mission.
With Juno.
And that's our largest effort to date in citizen science. We have a camera on board called JunoCam. We open it up to the world, say, hey world, where do you want to explore? So if people really feel like it's for them and that we are exploring for them, and so this citizen science, and we learn so much in terms of our, our astronomy and all the stars, that we open up those databases and let people find, new stars. Do you know about exoplanets?
Exoplanets.
Exoplanets. We have thousands of exoplanets. Yeah, Joy.
Where are they hiding?
They're there. Far away. So we actually put up 1,200 exoplanets on a put in a catalog and put them up online. But there's a couple dozen we call in the Goldilocks zone. The Goldilocks zone. So we really care about, a couple dozen of them. Why the Goldilocks zone? It's not too hot. It's not too cold. So life could possibly exist. Just right. And again, back to that enduring question. Are there other habitable planets? And these exoplanets, especially this couple dozen, we're on it. It's really fantastic. 20 years ago, that wasn't a discipline. It wasn't a field. Now you can go into astronomy, you can kind of specialize in exoplanets because there's so much to find. It's really amazing.
On the Milk app, you pose the question, what do we do? How do we bring boys and girls into space?
And when we open it up again, and I think we tell them, we change that conversation, we say, it is for you. We need all good thoughts. So no matter what young people like, if it's science, great. If it's engineering, great. Math, but if it's not, that's okay. We don't want to make STEM a thing. It's not a thing that you're either in or out. You need to open up that conversation and say, you want to explore? Then guess what? You're in. That's the conversation I like to have. You're in. Because most people don't know. At NASA, guess what? We have a whole bunch of financial people, right? We're passing budgets, working on budgets all the time. We need every different discipline, political scientists to the historians. So it's not just the scientists, technologists and engineers. It really is, especially in the federal government, saying we need everybody. And we'd like to have everyone because we need excellence. I just say it very simply, diversity, inclusion equals excellence. To be excellent, we just need to open it up and get all the best and brightest folks.
So there's also best and brightest working in private industry right now, and there are some, I guess, I don't know if you'd consider them competitors to NASA,
No, they're
but
partners.
there are enterprises that are trying to find their own way to Mars even, racing you, in effect, to Mars.
Well, we're in it together. The great thing is at NASA, as a deputy, I get to be in charge of all partnerships. So that's public-private partnerships, and it's with international partners. So with the private folks in the U.S., we are betting on them. We're counting on them. We're funding them now. So it's really a new way. It's disruptive innovation. It's a new way to do business for the government. We're saying to the private folks, we want to buy services from you. Right now, cargo to International Space Station, crew coming up in the next year. And then getting on to Mars, we have a Space Act agreement signed with Red Dragon because we need that data. We want instrumentation. We have to, when we get to Mars, we've had 50 years of great success. The world has. Most of the missions from NASA, we lead in getting to Mars, but the world's in it. The Indian Space Agency has an orbit around Mars today. We have 2 rovers at Mars and 3 orbiters today for NASA. And so all that data we're sharing. But what we know how to do is land 1 to 2 metric tons of payload on Mars. To scale that up for a human mission, 10, 20 metric tons. So we go about it, we have to figure out, it's called entry, descent, and landing. When you're coming in, you got to keep the humans safe and well. So that's the technology developments, but we're partnering with the private sector really on all 3 missions of our journey to Mars, from low Earth orbit, and we're counting on them. We're looking forward to the commercialization of low Earth orbit so that we can get on with going to deep space and going to Mars. So not competition for us, we're trying to seed the funding, make it economically viable. We're counting on their success. And then, again, for NASA or the government, we can go further. But this partnership, now, if the industry folks are kind of in competition with one another, that's good. Because it makes everyone better. They strive for excellence. So if they can push each other, that's a good thing.
That's good for you guys. As you can see, David Newman can answer any question you have about space exploration. So I want to encourage you to start lining up for that. But I think about that, and I think, there are going to be people in the political environment who are going to say, well, look, if Elon Musk is going to spend his billions, or Jeff Bezos wants to spend his billions, let them do it. Why should we continue to support NASA, or maybe even expand support for NASA? with
I hope
our taxpayer
right.
dollars.
Hope we can expand it because again, it really is critical. It's important if you want the U.S. to lead, which I do. If I want NASA to lead, and it really is partnering. And we're working. It's not for not even one nation. Definitely not one agency. So with the private sector, it's great that they're putting in that they're space nuts and they're excellent engineers. But again, the systems and the capability. Wouldn't it be great? We need some redundant capability. And we need to buy services. So now we're really comfortable buying some services, and especially if the costs come down. But then there's things that the business case doesn't close for. And so those are the things, again, where the investment in research and technology, what's good for America. That's where the government interest is there.
And only the government can do it.
The government can do it, and the private sector can help as well, but I think it's incumbent upon the government to make those investments. It is for the next generation to work with private industry to really look at those relationships. How can we do it differently to leverage and maximize? So we have Space Act agreements. We have 750 partnerships and agreements with 120 different nations. So if people want to work with us, we're saying, yep, we're all in. We'd love to partner. Sometimes it's just information, and Earth data. Get that around the world. So it's anything from Earth data all the way up to, exploring the solar system.
We'll see. All right, questions in our audience?
Bob Massey from Indianapolis. Thank you for this fascinating conversation. There seems to be an expectation that we will find life, probably some form of life on Mars, or at least a vestige thereof. In the popular imagination, alien life is a threat to human beings, but in recent conversation, there's some sense that we could be a threat to life on Mars, microbial life, for what we bring. How do you imagine mitigating that threat?
Thank you. That's a great question. So we do take that very seriously, and in terms of we're going to Mars to look for the evidence, probably past life. I think it might be 3.5 billion years ago when Mars really could have harbored life, but it's kind of like being a fossil hunter. Now there's some more characteristic signatures, but we have something called planetary protection, and we look at forward contamination. We don't want it to be, we search for life on Mars. We sure don't want it to be Earth life. Right. So the forward contamination, we have to make sure that we find life, it's Mars life, and then the reverse as well. So we call it forward contamination, backward contamination, because we'll get samples, bring them back. So we have the highest standards, and now not just for NASA, thinking about planetary protection, as well as forward, backward contamination. It actually go up to the UN level, because again, this is for the world. So to really get the UN, get the world involved, because it's not US law and regulations, this is governed at the UN level. So working to see what's the planetary protection, again, for forward and backward. So that goes through the UNs and the Committee on the Peaceful Use of Outer Space.
Yeah. Certainly, I think it's a very important thought. I mean, when we've had exploration on our planet, there have been those events where we have brought something from somewhere else. Other questions in our audience?
Lee Herman, Chicago. I'm really pleased to hear your message of inclusion. This is kind of a farther forward question about that, and part of the reason I think government involvement is so important. How do you see the longer-term evolution of rules and governance as we actually start to establish longer-term? The answer you just gave really kind of addresses the exploratory stages we're at now. But as we get toward actually putting settlements on other bodies and starting to have commercialization of mineral utilization and other kinds of resources, how do you see that evolving, and how do you feel the future for that is, given how political that's likely to be?
That's a great question. And so the good thing is, again, we need to plan for it. When we talk about that, again, utilization of resources and things like that, regulation. And right now, in the U.S. and through our regulatory agencies, NASA's not, but through working really closely with our regulatory agencies, say the FAA in this case, just for launches and thinking about the future of resources from asteroids to the moon to Mars, having that discussion, but we need the guidelines. We need so really now calling all lawyers and political scientists, and you talk about this. There's some examples on Earth, but again, I don't think we've gotten it exactly right. Treaties of the sea, actually looking to Antarctica is one of the better models, and so, and again, elevating that, and then it will be a discussion at the UN level in terms of international, thinking about international treaties and regulation. And
So who owns the galaxy?
Yeah, so it has to go, so it's all of us, but this really means all of us. So we have to have the discussions at the UN, and there are committees formed, and that's where that discussion happens, because it really is for humanity, it's for global exploration, so it's not just one nation, so we have those discussions at the UN level.
We are running down our time here, but if, in this political environment of the moment, if you could speak to each of the candidates for president, what is your message about the importance of the future of space?
The importance of future space is that we have ambitious, bold, audacious plans for this journey to Mars and exploration of the solar system, but we're doing it. We're making our milestones, and so we'd love to stay the course. It really is. I think the inspiration, the goal, and we're clear about our journey to Mars. So we'd love to tell our story. We'd love to educate people about what we're doing, and I think it's so good to bring everyone on board, because we need every single person.
And to have good leaders. Thank you very much.
Thank you very much. My pleasure. Thank you.